I'm Alan Grosvenor, and this is Simulations, the podcast. And I'm joined today by Robert Howe, Nuclear Operations Advisor for Tam Fortis Solutions. Robert, we're at TEVCON in San Diego this week, and wow, this show has been incredible.
This show has been incredible. We've met a tremendous amount of people here. We've been able to explore our technology, partnerships with other companies. It's been amazing.
And right across the way here, we're looking at a carrier, and you have some experience with submarines and carriers.
That's correct. I spent 9 years in the U.S. Nuclear Navy as a nuclear reactor operator on both submarines and aircraft carriers. I also spent 14 years at commercial nuclear power here in the United States, outside of Boston, Massachusetts, and achieved the senior reactor operator license level from the Nuclear Regulatory Commission. Did all kinds of jobs there. I've spent some time at Tesla, at Lawrence Livermore National Laboratory and other national laboratories, and most recently at Commonwealth Fusion Systems as the Director of Safety for a wide variety of projects.
So you've essentially taken a tour around all the most challenging, hardcore places that you could possibly work.
That's very flattering. Yes, it was my ambition to take the training received from the U.S. military and apply that in some diverse and challenging ways.
You must have some incredible stories from your days with submarines and carriers.
Absolutely. All around the world, crossing the equator many times, setting technically some sea speed records across the Atlantic from Norfolk to the Straits of Gibraltar. Yeah, lots of adventures.
Wow. And what's some of the most remote locations you've been able to poke your head up after working so hard day and night?
I think the most memorable was the South Seas next to Tasmania. That was a memorable event. We left there in the middle of winter in the southern hemisphere and experienced over 30-foot waves, which to most boats would be pretty challenging, but for a 1,300-foot long aircraft carrier, barely moves the boat around.
Yeah, that's amazing. And you glazed over your amazing NRC nuclear operations credentials. What was it like achieving that?
Thank you.
What did it take?
A very challenging process. There's only about 4,000 of those nuclear reactor operator license holders in the United States at any time. They go through a 2-year process through their own training evolutions. It starts with all the different systems that are in a nuclear power plant. It brings them together for normal operations, abnormal operations, emergency operations, and then what we call beyond design basis accidents. So you're exploring a comprehensive range of how every single system works when it's working correctly and when it's not working correctly. A lot of that is informed from the amazingly long operating history of reactors in the U.S. Navy and across America for the last many decades. I had that license back from 2007 all the way to 2017 and used that knowledge kind of as my nuclear PhD to explore other opportunities around, including Tam Fortis, and it's the kind of expertise that I hope to bring here to make our decisions even better.
Amazing. And speaking of making decisions better, at Tam Fortis, we've been focusing on building a deployable unit to remote operations locations to be used as a plug-and-play solution for people who are not nuclear operators. And so the idea of this extraordinary experience that you have in nuclear operations and licensed to do that, the idea that a unit's going to be used by non-operators, that must be like a shift in mindset. How do you feel about that?
Absolutely right. This is a complete paradigm shift, and we're convincing folks here from Defense Innovation Unit and the Army Fuse Unit how our technology is different from what they have established as the norm for American nuclear operations. Traditionally, a nuclear power plant a nuclear aircraft carrier, it takes an operator 2 to 3 years to get that training on all those systems to certify and demonstrate that knowledge level to be able to operate a nuclear reactor. Our technology, fundamentally different in that we've created a walk-away safe combination of technologies with AI oversight and human in the loop or human out of the loop options to provide safeguards for this reactor design to be safe under all conditions in which we envision deploying this in the field. Fundamentally different.
And before talking about the AI parts, which is a total value adder if you do it right, which is a big if for some people, there's mechanical engineering, there's nuclear engineering that enables us to fundamentally design it to be inherently safe, fault tolerant, able to take some bumps.
Absolutely. Just with the reactor core design, which I think is the specialty that I'm trying to bring to this, we're using a fault-resistant fuel technology that is what has already been tested from 2009 to 2020 through national laboratories and through government laboratory studies that say this is meltdown-proof. You can't get it hot enough to destroy the core, as has happened in previous accidents. We're using metal moderators and what hold the fuel in place to prevent it from being able to change its geometry. We're using solid state cooling technologies that do not require pumps and valves. There are no moving components to remove the heat from this that are traditional failure modes for previous reactor designs. And then we have shutdown technologies that not only control reactor power through its range, but verify through the use of AI monitoring tools that it doesn't exceed the design parameters and that it is shut down completely in the event of any, what we call again, beyond design basis activities.
Amazing. And, you know, there's so much garbage out there in artificial intelligence. There's a vast ocean of people that are claiming everything.
Yes, there are.
And they're training on, you know, garbage
Reddit.
in, garbage out kind of data and outcomes. But the key is, if you actually know what you're doing in artificial intelligence and you're sophisticated, you have sophisticated tooling, compute resources, and you're marrying that kind of expertise, those kinds of resources, with domain knowledge.
Yeah, you've got it absolutely right. AI is a tool that if you feed it the wrong information, you're going to get the wrong information out. But what we're doing here is feeding it a huge range of reactor protection system parameters, and we're saying this is what you're monitoring. And so you're really creating a more of a closed algorithm that says, how do I monitor these parameters? And given this wide range of inputs and trends, how do I make sure that my reactor is safe through this comprehensive range of scenarios? And the AI, and I don't want to make sure that I'm misstating anything, not the AI expert, I am the nuclear operations expert. I can feed in the correct parameters for our partners in AI to say, this is how we get the correct output parameters.
You mentioned that you worked at Tesla, and one of the really cool things in my mind about Tesla, out of many, is not only have they federated learning from all the vehicles in the fleet on the roads and generating billions of miles to train their autopilot,
Yes.
but also they simulate rare situations. And that's what we've been doing as well. Of course, you don't want to design the reactor first and then mass produce them and then wait for a bunch of data to come in before you start being prepared to train the system to recognize anomalies and what to do in those situations. And so there's a huge opportunity for simulation that we've been really utilizing here.
Yeah, we're very lucky that we are partnered through some organizations with supercomputers at some of the best computers in our nation at government research laboratories. Those give us the ability to simulate hundreds of thousands of times different sets of parameters, different combination parameters, different trends, different acceleration rates, so that we are sure that our AI solution is able to monitor throughout a comprehensive range of operating conditions, even beyond, so far beyond what we think is going to be the normal day-to-day 0 to 100% power. And this gives us real tremendous confidence that what we're putting into the field isn't going to be a situation where, oh, we're planning on, or we're thinking we may discover something new. We've simulated all of that more times than we can count, so that what we're putting into the field is so much safer than anything that's been done before.
In addition to your extraordinary military experience, you have all these extraordinary industry experiences. Talking about Tesla again, you joined and then started leading, and you experienced and were part of radical changes in parts of the organization during those days. What was that like?
Well, that has been really kind of the status quo since leaving nuclear power back in 2017. With Tesla, with national laboratories, with some robotics and automation startups, and most recently with a fusion startup. It's a very dynamic organization. It's a very dynamic lifestyle. It's really what changes the mindset from really very stable commercial and nuclear power into this kind of organization where we are anticipating a dynamic atmosphere within which to demonstrate and deploy our technologies. That journey has brought me through standardized thinking, where everything is in a book and everything is already pre-diagnosed, into a much more responsive technology, not waiting for things to happen, but going out and looking for them. And I'm very much happy that I'm able to bring that to Tam Fortis to say we can go out and really demonstrate and conceive a range of activities within nuclear operations envelope to make our product so much safer, so much more capable in a range of situations. We are dealing with technology that doesn't exist. We are creating a paradigm that doesn't exist, and that requires, in today's day and age, where you've kind of got a limited shot at making things work, makes us so much more viable as a company, so much more viable as a product.
Speaking about technology that doesn't exist, you were at Commonwealth Fusion, and they're making that exist, and it's incredible the progress that they've been making. Likewise, what we're doing today is only a consequence of the new renaissance in nuclear energy, the fuel supply that's being stood up, new recycling programs that are starting to happen, and because there are all these megawatt plus microreactor companies that are focused on installations, and what they're doing and what's being proven out, and the change in mindset about the need and the solutions has really opened up an avenue for what we're doing at Tam Fortis Solutions at the totally opposite end of that spectrum, where we focused on answering the question, what would it take to deliver a box by helicopter or on the back of a pickup truck, make it robust enough that someone's going to drop it, it's going to see some action, and they're going to use it as a plug-and-play solution. From your perspective and from these prior experiences that you've had, you've seen these kinds of shifts in other areas that you've worked in.
Without a doubt. And you put it well. This might be one of our, certainly not our greatest challenge, but one of our significant challenges is to allow others to recognize the paradigm that we're solving here. Every nuclear company in America is saying, how do we do something that's already been done better? How do we do nuclear 2.0? And what we're trying to do is saying, how do we do nuclear 4.0 so that we're not designing a nuclear reactor with newer, safer technology, but we're really changing the entire paradigm of what nuclear can be applied to. A lot of companies out there today, terrific companies, are doing a lot of terrific work that says, let's use nuclear in a sense that it's been used before. An installation with a lot of shielding, concrete bunkers that doesn't move. Maybe we can get it to the factory to there, maybe we can move it around once. We're doing something tremendously different, which is how do we build a nuclear-powered electrical solution set that can move again and again and again and again. And here at TEVCON, we've heard from military experts in their fields that say that would solve this challenge, that would solve this group of challenges. And it hasn't been just the Army or the Navy or the Air Force, it's been all of them. And then we're finding other non-military partners that are saying, hey, we can use that in disaster relief, we can use that in this range of applications, which just keeps growing and growing and growing. The value of TEVCON has been for us to help change that paradigm about where nuclear can be used, and also talking to our potential partners and a range of military sources to say, what is the problem that we can solve? And they've been giving us overwhelming number of answers. It's hard to keep up.
And also, there's some consistent themes that keep on emerging. We've had a lot of people tell us, give us a unit that you do not have to be a specialist to operate. And give me a unit that we can put on a vehicle to achieve unlimited range, no signature, something that you can infill and exfil.
Absolutely right. Our unit can go anywhere. It can be deployed by a helicopter, inside some helicopters, underneath smaller helicopters. It can be put in a JLTV, Joint Light Task Vehicle, in military operations, or multiple units within a heavier unit. You could put a trailer and put a half a dozen of these in it in many cases. You can put it on a boat and take it to an island. There's just no limit to the applications that the military could use our technology in. And the same thing would go for an emergency disaster response from FEMA, where you could say, let's have 10 of these in a trailer. Let's have 20 of these in a cargo shipping container. And FEMA responds to an event and says, now we have distributed nuclear power, electrical sources, anywhere we need them for as long as we need them. And even, the most tremendous disaster sites are going to benefit from these in a range. Then we talk about, and this is what varied groups throughout the military are bringing to us, they have operational security concepts that we haven't even talked about yet. And they're saying, we need more of these around our base so that if there's a potential infiltration, we don't lose all of our electrical supply, we only lose a piece of it, and then we can teach them how to connect these in different ways to provide them energy security even upon the loss of one or multiple units when there are units around their forward operating base.
And it's absolutely incredible. You hear about dual use technology. It's emphasized over and over again for military contracts. They want dual use, and we truly have the most compelling dual use applications. We're supplying a solution to change the paradigm where they have been using diesel generators, which are noisy and attract drones, and they're constantly having to run more fuel out to them, which is a logistics nightmare. But when we're talking about commercial applications, remote industrial operations, charging electric vehicles, charging robots, community microgrids, you talked about emergency disaster first response. This unit, the size and the output that we've designed it to, has given us a huge amount of opportunities.
Tremendous amount of opportunities. You're absolutely right. There's just no limit to what the imagination can do when you say we can produce electricity for a minimum of 5 years, up to 10 years, on demand. We can modularize this so you can stack them up and meet your load demands to whatever it needs to be. If you need 50 kilowatts, 100 kilowatts, a megawatt, we can do that, and we can do it in a mobile package that can redeploy over and over and over again.
And, by the way, at TEVCON, this amazing community comes together where we have industry, national labs, multiple branches of the American military, all here in one place. And we're hearing from all of them and exchanging ideas together. And, a small room where you'll have a head of something NRC, and
That's
then
right.
Idaho National Laboratory, and then we have Army folks and Navy folks. It's amazing how we've been hearing very compatible perspectives from all of them, and everybody understands that now is the moment. Things are changing right now.
We've talked about how our technology is a paradigm shift, but the United States and even the world in a larger sense is going through another paradigm shift. And that's where we recognize we need more electricity for a range of solutions, whether it's AI data centers, whether it's our warfighters in the field, whether it's the American grid is reaching capacity in some areas and needs to think about new solutions. Our technology has the ability to apply to so many applications, only a fraction of which we've talked about here today, that being here at TEVCON and having these diverse multiple sources that haven't come together before now to say Army, Navy, Air Force, Marine, Space Force, we're all looking for something. Oh, wait a minute. You have a good solution here. And then we hear from maritime solutions. We hear from electric vehicle providers. We hear from other providers that have technology that, yes, of course, they need electricity. And they're like, well, we want to deploy this way over here. Well, there's an opportunity to partner. Our technology can supply that. And they come over and they're just amazed at what we're able to do because they hadn't foreseen that ability. With changing grid conditions, with the way that technology is advancing, with America's challenges compared to other countries, with AI, there's more opportunities than we may be able to fill. But there are some government sources here that are saying, hey, we have $1 million, $1 billion, $100 billion that we are actively, eagerly trying to find solution sets. And Tam Fortis has been one of them, and they're showing us the door. Apply to this program. We want to see your technology succeed.
This nation has the most incredible resources that are necessary to pull off something like what we're working on, and the industry represented here is. And it's special shout out to Idaho National Laboratory and the folks that we're so lucky to be working with at Oak Ridge National Laboratory and Argonne National Laboratory. We're in more recent conversations with Lawrence Livermore. Even the Navy's Fathom Works, which is an incredible facility and resource. We're so extraordinarily fortunate to be able to have new entrees with some of them, collaborations and partnerships with some others, and we're bringing together so much from so many different highly specialized folks with differentiated resources, and it's exciting what it becomes possible when you bring so much of that together.
I totally agree with you in singling out Idaho National Laboratory among this, star-studded array of national laboratories. Argonne, Oak Ridge, Lawrence Livermore, and others. But Oak Ridge is really like kind of the belle of the ball right now. Yeah. They're receiving so much attention, well-deserved attention.
Oak Ridge and INL too. INL is like a center of the universe for nuclear right now.
And with their National Reactor Innovation Center, with their demonstration of microreactor experiments, with many of the other functions, they're staffing up. They're receiving the expertise and the funding and the support to make this happen, all on the backs of the executive orders that came out in May of 2025 that says we are reinvigorating in a new nuclear renaissance, the nuclear industry in America. And Idaho National Laboratory, you're taking point on that. And Nuclear Regulatory Commission, and we heard from Dr. Jeremy Bowen this week, one of the directors at the Nuclear Regulatory Commission, how that's happening. They're changing the way they do business, and it's so much for the positive, so much in keeping with how fast we need to move and how we need to accelerate our technology. And I just can't say enough about how positive our interactions with Idaho National Laboratory have been, and how we've seen their expertise filling the needs that the president and the executive orders have said, this is how we have to move. INL and the NRC are doing it.
I'm so glad that you mentioned Dr. Bowen and the total paradigm shift that he was talking about of the way they are truly helping companies wanting them to succeed now.
Without a doubt. My experience in the nuclear Navy and at commercial nuclear power, it had a lot to do with licensing. And my own, whenever a licensed operator is certified, it's by the NRC. I've been through that process in meticulous detail. And to see Dr. Bowen come here at the director level in the NRC and say, we've seen what we've done before, we understand the paradigm associated with the NRC, that's changing. And he said it over and over and over again. Here's how we're doing business. Here's how fast we've changed. Here's how we've cut our response time in half, or by 75%, or by 90%, and how we're not satisfied with that, but we're going to keep going to make that even faster. That was a paradigm shift for me, to say, I've been used to this industry for 25 years, and I've come to say, this is what I expect of the NRC. And then he comes here and completely changes my mind. And then we get to sit down for, a cup of coffee and really get into it and say, well, why is it so different? And he said, this is why. It's these executive orders. The country needs to change. The NRC is changing. And really amazing paradigm shift, amazing shift in, a government organization which perhaps some of us didn't think was capable of change. He proved me wrong. They are capable of change. They are making that change happen.
I was so thrilled. He told us he didn't know this is happening, and he's happy to hear about it. Furthermore, Part 53 just came out. He was talking a little bit about the coming Part 57, and that it should be relevant to our endeavor. There's never been a better time to introduce true mobile nuclear. If you had to succinctly summarize what you think are the most important elements of this reactor, what would you say?
The most important aspects of this reactor, from my perspective, are its compactness and its ruggedness. This reactor is solid state. It has no pumps and valves. It does not need water. It uses all solid state materials and these might be technical terms, in the moderator, in the cooling, and in the control mechanisms that make it ruggedized so that it can go anywhere and continue to develop power. And that's just the reactor core. Inside of our unit are also vastly superior technologies of supercritical CO2 and a printed circuit heat exchanger that reduce the size and increase the efficacy of those heat exchange processes multiple times over compared to existing. I came from a nuclear power plant that was 900 acres. It had an array of buildings. It took 2 hours to walk around those buildings. And our turbine hall, now this is a generator that produces 40 kilowatts of electricity, and the power plant that I worked at produced about 1.3 gigawatts of electricity, but just a tremendous difference in the technology. No steam, no water, no valves, no pumps. This is
supercomputers in the 1990s or before would fill up a room, and the compute power that you got from those systems, we got on our iPhone today.
Correct.
There's a lot that we have found that we're able to do to make a truly compact mobile unit today. And it's incredible to be working on this project and what's actually possible right now.
I agree. The compactness of this technology, and your analogy is accurate. You go from an entire building that is a computer to something that you hold in your hand. We're doing the same thing with nuclear technology. This technology, a lot of it exists in many other designs throughout this newly renaissanced industry. The TRISO fuel, the control drums, the metal hydride moderators, these are things that almost that a wide array of our partners in this field are using.
They've demonstrated it and brought it to high TRL, and we're standing on the shoulder of those giants. And they, because of their work, we were able to say, okay, what does it take now to integrate and do some miniaturization?
And that's where we're different. That's where we stand apart from our others in the industry. We're doing something so compact where it's about mobility. It's not just about the use of newer, more efficient technologies.
Robert, I could talk about this stuff with you all day long. Thank you.
Thank you very much.
Nice conversation. Appreciate it.